This didn't want to. You're telling me that it is 17 degrees here. Suddenly I feel cold. Give me a second. Hey. I didn't feel that. Okay. Yep. Okay, no, this is Codex. That answered my question here. That's a small question, just one page. Yeah, this is text interface. Those formulas are a bit hard to read. Well, this is code, but there's some mathematical formulas in it. Formulas. Yeah, all you need is the code. In code with line CS direction and the same C1 and C2 used to build a hyperblock that is using vector type blah blah blah. I think we need to be in math hyperblock. We should start at the top. In the line direction we have is line CS direction in detail intersect. There. Let's have a look there. Okay, well, this thing is doing is calculate the intersection between a line and a rectangle and return the number of intersection points found and an array containing the intersection points. The line has a direction. This direction will correspond with the direction from the point returned as index 0 of the array to the point returned as index 1. The points, well, that is broken, so we're going to fix that. The points are returned as point CS. The caller is responsible to make sure that the rectangle uses the same coordinate system. Okay, and CS stands for coordinate system, I'm sure. But what is it? Doesn't really matter, I guess. It is just a coordinate system. And everything is using the same coordinate system. At least caller is responsible to make sure that that is the case. So we have a line in this coordinate system and we have a hyperblock which doesn't know about coordinate systems. That's why the user is responsible for it. But I put it in the name, you know, as it must be the same coordinate system as this one. Having the line, you also have its direction, namely line CS direction. And then if you swap the x and the y coordinate and make one of them negative, in this case the y coordinate, then you get a normal. Normal being perpendicular to the direction, right? So this one is rotated 90 degrees anti-clockwise, relative to the direction. And then having that normal, create a line. A line is being created from its normal and some point on the line. Well, why is this point on the line? Is that a point on the line? Is it a point at all? Looks like a scalar. No. B here, that is an offset. B must be equal to the negative of the normal dot product with P, where P is on the plane. On the hyperplane. So in this case our hyperplane is a line. Very hyper. So we need a point on the line, and I think the line just is defined in terms of a point on the line plus the normal. So we just calculate the dot product between those and then put a minus sign in front of it, and that's being passed here as B, and then we have the hyperplane. Okay. Yeah, so here's the minus sign, and the dot product is just normal x times something and plus normal y times something, where something then is that point. So the line CS point is a point on the line, and we just take the x coordinate here and the y coordinate there, multiply that with the same coordinate from the normal, then we have the dot product minus in front of it. This totally defines that this line goes through that point. Yeah. And then we calculate intersections with a rectangle CS, which is a hyperblock. And we pass it the line, which is a hyperplane. So actually it calculates the intersections between a hyperplane and a hyperblock. Although the number of dimensions is given here, but what we are calling doesn't know that. And I think that what this returns is a vector, I bet. Intersection points. Yep, it's a vector. It's a vector of intersection points. And I want them to be already in the correct order. So we have to fix this function. Then they are in the correct order. And then if the line is cutting the rectangle at all, the rectangle of the window, then it is not going to pass a single intersection. I think that if we go exactly through the corner, it just returns the corner twice. Or maybe not, and then we will assert here. Anyway, below this line we assume that there are two intersection points. And they are added as follows. I mean, we return here an array, well, a tuple of the number of intersections points and the intersection points themselves, being two of them. And then the points are well constructed here, and this one must be the first point, and this is the second one, or first meaning, in this case, if we come from infinitely far away, and we follow the line in the direction of its direction vector, then we will enter the rectangle by crossing the outer border of the rectangle. And that is then the first intersection. That should be stored here. Now we leave the rectangle at this point. That's how it should be. But currently this function returns the intersection points pretty randomly. So sometimes it works and sometimes it doesn't. Well, later on I catch that, so we assert if it doesn't work. But yeah, I'm going to fix this. Let's see. We're going to need the direction of the line somehow. However, what is being passed is a hyperplane, where we only have the normal of the hyperplane. And well, whatever, the hyperplane has a certain formula, this one, that defines the hyperplane. Now, unfortunately, it is not the case that we can directly use the normal, I think, because yeah, here I want to draw something. I have to go to a website, I guess, where you can draw. Where's my browser window? Yeah. What was this called? Sketch. Does that work for me? That works. Okay, so we have a rectangle. Very good at drawing rectangles, as you can see. And we have a line, and the line has some normal. And the normal was counterclockwise relative to the direction, right? So that is the real direction. We just constructed the normal from that by rotating it 90 degrees counterclockwise. This is the normal. This is, I don't know, call it the direction vector. So this is the first point, because we follow the direction, we come in here, and then we find this point first. So let's call this F. First point. And we leave it here, second point. That what we are going to do is determine, well, we find this intersection point by the fact that this corner is on one side of the line, which we do find by using the normal. And the normal defines, well, this whole half infinite plane here is on one side, which is where the normal points to, and then this is the other side. So this point is on one side of the line, that point is on the other side of the line, and we randomly check all corners until they, by accident, fall. We could test these, for example, these two, and they are both on the same side, so we don't pick that one, and then we do another one like this one, and hey, they are on the different side. Or maybe we use this one and this one, and then we would find that one first. So that's very arbitrary. We don't know which one we find first, but let's say we find this one first. And then we find that one because this corner is on one side of the line and that point is on the other side of the line. Therefore, the edge here must cross the line. And then what I'm doing is I am going to assign a vector to each corner. You have to think in higher dimensions. I mean, now this is two-dimensional, but it could be any number of dimensions. This thing is really a hyperblock, and this is a hyperplane, which is just one dimension less than the hyperblock. And let's say the rectangle is maybe a cube, right? I mean, it's one dimension, only one dimension more, but still. Then I'm going to assign a vector to each corner that points to the opposite corner, which is pretty easy to do, because all of these corners have coordinates like a binary number, right? I mean, okay, this is all 5-dimensional, maybe more. It's just a binary number. And the opposite one is simply, well, the 0 turns into 1 and the 1 turns into 0. So we have here 0, 1, 1, it becomes a 1, 0, 0, and then the rest is 0 becomes a 1, 0, dot, 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 0. Yeah. So just invert invert the bits, and then we get the opposite corner. So this one has that as opposite corner, and then I can draw a line between them. And if I take this as coordinate, the coordinates of this point minus coordinates of that point, then we get this vector. And this vector points, you can, well, I'm gonna divide it by 2-ish. That doesn't really matter actually, but let's do that. This is the center of the hypercube. For any number of dimensions, this works. And then we just subtract the opposite corner minus this corner, and then divide it by 2, and then you get a vector from the corner to the center of the hypercube. And every corner has such vector. It is easy to calculate, of course. This one as well. Oops. And if now we find that this is an intersection point on this edge here, then I'm going to add this vector to that vector, and that then will give us, and then divided by 2 again, whatever. Which means that this edge is in this direction, so I'm going to draw a line here through the center of the hypercube. And then this plus this divided by 2 is going to be a vector perpendicular to the edge, pointing to that axis here. This is 90 degrees. That's the trick we are going to use. Then 2 dimensions. I mean, this in explained in 3 dimensions, but it works obviously in any number of dimensions. And we will end up with a normal, something that is a normal to the edge, and it will point inside the hypercube. Yeah, I mean, this is outside, and this is going inside. So if we do that here, we have, well, this is a rectangle, but we're going to normalize it. We make one corner the origin, and so this is 0, 0. And then the opposite corner is 1, 1. And then of course this is 1, 0. And this is 0, 1. And that's the coordinates that we're going to work in, even though this thing is a rectangle. So that means that my vector, this thing has a center here. We find this corner and this corner to be on the opposite side of this line. Therefore we know that this point is somewhere on this edge. And now I'm going to add this vector to this vector and divide it by 2, and that will give us What will that give us? Well, that should give us this vector. And this vector then has coordinates 0, because it's not moving horizontally, comma, plus 1/2, going up. Note that if we would find this one first, so we would find this corner and that corner, then we would have added this vector and that vector, which would give us that one. And that has coordinates 0, minus 1/2. Also pointing inside the rectangle. Furthermore, we have the direction vector of the line. We're going to normalize that so that it is in terms of these corner coordinates. But that doesn't really matter. It's just this direction vector, and the length isn't even important. So maybe, I mean, even if I don't scale it, well, it is a different X and Y are scaled differently. So maybe that makes a difference. I doubt that actually, but okay. Let's just say that we end up with some vector with what should be a length of 1. Yeah, the whole thing is stretched. So what is 1 here? I don't know. Well, actually, I should know. This is 1, and this is 1. So if we rotate it a little bit, it should be a little bit longer. Thing from here to there is a distance of 1, and then, but here it should get longer. So maybe it's more like from here to there or something like that. But at least the direction is clear, right? And then if you take the dot product with this normal to the edge and the direction vector, then that is positive. Positive meaning that that is the first corner. And if we would have done that here, well, the direction vector is still the same direction. And then if you take the dot product with the normal here, then you get something negative because the angle is larger than 90 degrees. And then that being negative means that that is the second one. So that is going to be how we find which is F and which is S. And we need to do some work for that. That was not what I wanted to type. I wanted to do Control T. Okay, but we do have to go to intersection points. Oh yeah, the problem was that we don't really have the direction. Well, the line here is the hyperplane, not the real line. We have the normal. So this whole what the hell, man? Just stop doing that. So this we can calculate this normal to the edge, but the direction vector, you know, really have it. You have the normal, but you can't use the normal because, I mean, the dot product between the normal of the line can be also negative here. I mean, dot product between the normal of the line and the normal of the edge is positive here. But if the line would be like this, and in that direction still, this is still F and this is S. But now the normal is like that. And then the dot product between this normal and that one is negative. So that does not work. How can we remedy that? Now it's easy to rotate the, well, easy. You could rotate the normal clockwise 90 degrees. And now we get direction vector back. But. After all, I'll not do that, you know that. Don't ask me why not. It's a very long story. Well, if I refuse to do that, then I would have to rotate the normal of the edge as well. In other words, if I want to work with the normal of the line, let's take this line again. Can I do an undo here? Control Z or something? No, that totally works. Well, that actually was the normal line, but then not drawn here, but here. So if you want to work with the normal of the line, you cannot take the dot product with the normal of the edge. You have to take the dot product with the normal rotated 90 degrees. Well, that's easier, I think. At least not as confusing. It doesn't really matter which direction I rotate it. It just changes the sign of the dot product. So if you always rotate it the same direction, then that will work. But must always be the same direction, right? So if we rotate it also counterclockwise, then this thing now has to be that one. Sooner or later, I'm just gonna want to have something red, I think. Still don't have anything red, of course. Feel it's probably more outline. Yeah. So, I want to. That's also filled. We want to find this, and then if our line would have crossed here, then we want to find that one, which is 90 degrees relative to, well, this normal. And we want to find that direction, and here we want to find that direction, and so on. Yeah. Let's look at the multi-dimensional case again. So let's say we have, I had this line here. Sorry, we had an intersection with this point here. And in the three-dimensional case, that would be an intersection between, a three-dimensional hypercube, which is a normal cube, and a two-dimensional hyperplane, one dimension less, which is a normal plane. So there is a plane that cuts through here, which means that, well, say that is the front one, and the plane goes, I don't know, let's say it goes to the other way, the other side over the bottom. Because this edge is an edge of two faces, the front face and the bottom face. And the plane would go something like cut here and guess like this. That is the hyperplane now. And then it depends on the face. Well, no, I just want to have something that, well, we had something that the black thing here that points inside the hypercube or inside the cube. And now suddenly I want to talk about a direction along the edge. So now you see why I hesitate to just say, oh, well, it's easy, you just go around. It's not easy. It's a cube. It could even be 4-dimensional cube. What is the logical direction here to go into? Let's pick another color because it gets so crowded again. It is about planes though, although we have two faces now. So I want to find there is no first actually. There is no first. What we have here is a plane that cuts through a cube. And I'm going to want to find a direction in the end. I just want to know if this is the first relative to that one or relative to that one. So here we just have a single direction. Here we're going to have two directions, going in an incoming and an outgoing direction. So let's say that this is the incoming direction, and this is the outgoing direction. Then it is the first for this line, but it is the second for that line. So there's no first and second anymore. And to find out, it is in the front face, this is the first one, and in the bottom face, it is the second one. So if we want to take a dot product with something, we're going to take the dot product here with the normal of the two-dimensional plane. And I wanted green here, but I don't get it. I didn't get green. Why not? Outline. Line with 2 pixels. I didn't want to fill at all. Luminous hue. I like that. Yeah, no sulfur. Much better. Yep. So I think that let's first think about the easy thing thing, like the normal, not the red thing here, but the vector that is perpendicular to the edge itself. Then we have here, well, we have two faces, but I did construct this vector here to the axis that is going through the center of the hypercube. And if I project that onto this face, well, that should be halfway again. So it doesn't really work out, I guess, but let's say here, project it down. It's 90 degrees, and this is halfway like that, but at any rate, within the bottom face we have this component. Of course, still making a 90-degree angle with this edge. And it can also project it onto the front face from here, which is of course the same thing, so that ends up here. I mean, it's that part here. It's now the projection, so we get then here this vector in the front face. Both are normals to the edge. So that's these two green things correspond to this thing here. Hello, GeoDev. And we want to take the dot product with the direction vector. Welcome. There's nothing to learn here. It's all way too difficult. I'm just, you know, doing my stuff, talking out loud. On the other hand, if I'm explaining it like this and I make drawings, then suddenly in my eyes it's simple. I cannot imagine that there would be anyone who cannot follow it. But yeah. Okay, so I wanted to take the dot product between the normal to the edge and the direction vector of the line. And now in this case the red things here are the lines and the direction vectors are, well, whatever, this direction. So this angle is less than 90 degrees, which means that the dot product is positive, which means that this is the first one, and this is the second one. Yeah, it's for the front face anyway. And in this case, we have, well, this direction coming from here, going there, or that way. So the angle between this one and that one is larger than 90 degrees. The dot product is negative, which means that this is the second, the exit point, basically. This is the first one, with respect to the bottom one. In other words, that determines, of course, the direction we go. We go around like that. But we don't know anything about, we don't have these things. It's just nonsense. We don't have that. We have the normal of the plane, well, the hyperplane actually. That's why I didn't want to work with the direction vector, you know, because in the case of a line you do have a direction vector, but in the case of a plane you don't have a direction. Any vector in the plane would be corresponding to this direction here. What we have is a normal. I'm gonna draw the normal in blue, as if that would make it easier to understand. Like this. Now we have blue. So this is our plane. Let's draw well, let's take the screwdriver rule. Rule, if the thing goes around like this, then the screwdriver would go, you know, inside the well, deeper inside the picture. So let's say we have a point in the plane here, and then I'm drawing a perpendicular vector like that. So that is the normal of my plane, making a 90-degree angle here with the plane. So this is behind the plane, yeah? That's what we have. We don't have this, we don't have this. So that's the same thing as saying that we don't have this direction vector, we have this normal. That's what we have. And if then I want to find out if it is the first or the second point, or the point where we enter the hypercube or leave it, then we have to take the dot product with not the normal to the edge, but 90 degrees rotated. But in which direction, right? Well, if I rotate this thing 90 degrees, you can rotate it two ways, this way or that way. But I want, this is the, wait a minute, let's begin with this one. Front face. The front face, it was the first one, so we want to get a positive dot product with that one. So clearly that has to point that way then. I mean, if it would point this way, then it would make an angle larger than 90 degrees. Huh? So it must be rotated like that. And it points along the edge. Very clear. But of course, it is exactly the plus or the minus thing, the first or the second thing. If we want whether or not it points in that direction or in that direction. But I know in the end it has to point in that direction. That would give me the right result. And now the other one, so this one here in the bottom face of the cube, that must make an angle larger than 90 degrees with this thing. After rotating it to the edge, so that must be rotated the other way then. This one must end up here. And now the big question is, how can I determine that? If I look from the outside of the cube to this face, then this is counterclockwise. That's something. And if you look from the outside of the cube to the bottom face, then this is also counterclockwise. But then in terms of the bottom face, I think hold on to that thought. Pretty sure that is the solution here. Now, having a face at all means we have a plane, and that plane is then defined by four corners having all the same coordinates except for two coordinates. Let's say we have something very many dimensions, but if you would look at these four corners, because this is the face that we're talking about now, then there's only, well, we have four corners like this. And all the coordinates are the same. except for two columns. Yeah, so let's say this column here and this column here. We have here different things. One here and a 0 there, and then this one is like this, for example. That determines which phase it is. And then we have to rotate this counterclockwise while looking from the outside. What does that mean? I think that just means that we have to swap these two. Those are the two coordinates. And then make one negative. But which one? Yeah. That is the question. That is the last question that we have to answer, and I can start running code, I think. It is even more complex because it really matters. I mean, this is a three-dimensional case, but we have really an n-dimensional hypercube. It gets way more complex. So maybe I shouldn't really care about that. Not really. Can I answer this for 3 dimensions at all? That would help a lot. Yeah, because this edge has 2 faces. But in 4 dimensions it has 3 faces. It's, I think, the number of, well, 2 faces anyway. So I mean, 2-dimensional faces. 3 2 faces. What is the difference? So this is the front face and this is the bottom face. Why? Are they always opposite? That's another good question, actually. I think they must be. They must always be opposite. So you go around here. Yeah, they must always be opposite. Because we go around, so this is, if it enters here and leaves there, the bottom face, then it enters here in the front face and leaves there, the front face. And then at the same point, this enters in the left face and then leaves here, and then enters at the top face and leaves there, the top face, and then enters at the same point immediately at the back face and leaves here on the back face. So every time the two faces that are that make up this edge, or every edge, is an entry point for one face and exit point for the other face, meaning that the dot product with the normal of the plane must have opposite signs, and we are now, well, we have vectors that are along the edge. So if I would have both on the same side, they would be the same vector and they would have the same sign, which is not the case. So one face as one of the faces goes with a vector that points along the edge in one direction, and the other face is in the other direction. So maybe it will help if I just draw all arrows, and every arrow for the cube. And at least, well, we have 12 edges, or 24 of those things. Maybe that will give me an insight how it really works. There must be some super symmetry there. Can I start anew without throwing this away? Can I just draw it in a corner here? I think I used to understand how to draw a straight line here. I've got. What the hell did I forget that? Pencil line. There we go. So let's draw a nice cube. Oh fuck, that's not the old. I think the line is correct, but I just have to click once and then put click to Y, I think. Yeah, click to Y. It's not a square. Oh, okay. Here maybe, yeah. And now make a cube of that. Move. Can I move this thing? No, it's not what I wanted. Damn it. Oh no, it's resizing. It's not what I want. Come on, man. You can just... Ah, that's what I wanted. Oh. It's not doing what I want. Line. It's still on line, so... Okay. Now it's on the hand again. Yeah, okay. Lip. Okay, my music is unbearable. Nah, let's see. So, the front face had an arrow that way, but why? Why is indeed the question. And it's still online. Maybe I should put it on arrow. Wow. Yeah, no, maybe a bit too much. Actually, maybe. So this, well, no, it's the front face. Yeah, that it's super unclear. Yeah, it doesn't work. Just do the pencil. Why was the front face that way? Jesus, why is this so difficult? Or I'm just, I don't know, getting stupid suddenly. It can it if it is correct at all. It can only be like this. Which explains what it is. Yeah. The logic is there. It's staring us in the face. I'm gonna pick another color now. Well, actually, I already have blue a lot. Let's take this on. I can't draw, but for the rest. Not too dark, not dark enough. Come on, I'm not seeing anything. Darker, darker, darker. The bottom face. Mess it up. Yeah, well, and so weiter. Is the... Well, will I do all of them? Nah. Yeah, I'm thinking at the same time, more or less. So it's not a total waste of time. Yeah, we'll just have to do yellow, I think. Let's go for it. Yellow for the back face. Right. Now this is completely rotational symmetrical, which means that you can rotate this thing until the 0, 0 corner is here, due to symmetry reasons. So I might as well fill that in. Why does the thing say not saying black? Black, black, black. So it is black. Yep. So we're gonna call this 0, 0, 0. And then again, for symmetry reasons, it really doesn't matter which is the x and the y axis. So I might as well say that this is the x-axis, and which would correspond to x, y, z, I guess. So the first one, we call this 0, 1, 0, 0. For the same reason, well, same reason, totally different reason. The opposite corner is 1, 1, 1. Okay, we have want to have a right-handed thing though. So if this is all going to be all zeros and ones, then, and this is the x-axis, then what is the y-axis? Either this one or that one. This one, right? Yeah. This must be the y-axis, otherwise we wouldn't have a right-handed axis thing. So this is 0, 1, 0. This is 0, 0, 1. 1, 0, 1. 0, 1, 1. And there is one left. 1, 1, 0. Yep. Okay. Why are these directions the way they are? Now see how beautiful this two-dimensional case corresponds to the front face, or any face for that matter. As long as you assume that you're looking from the outside. At the thing. Maybe to look at the bottom. The bottom is 0, 0, 0 for the Z. And if you toggle Z, then the directions are changed. So here they go. The brown arrow is going this way. And if you the z is 0 everywhere. And in this one, the top, it's going the other way. Why the z is 1 everywhere. So in the bottom plane we have these coordinates changing. And the rotation is, yeah, that way. It means that we go from 0, 0 to 1, 0 to 1, 1 to 0, 1. And then back to 0, 0. And our example in the left face. In the left face, the x-coordinate doesn't change, so it is the y and the z that change. Should have taken blue, of course. No, yeah, too late. Whatever color this is. And well, we go in that direction. So we go from 0, 0 to, please let it be, yes, oh, 0. Could be a coincidence. 1, 1, 0, 1, and then back to 0, 0. I'm afraid you'll just have to do all 6 faces before you can be sure that this is a pattern. Let's do green. This time I have it correct color. For the right face, and the right face is also x-coordinate doesn't change. So this one is reversed, actually. But you can explain that by the fact that, well, the remaining coordinates that I didn't draw here have a parity of 1. So maybe I should leave out everything that has a parity of 1, which is half of it, which means that I only have to do the other face, where 0, 0, 0 is a part. And I did the left face and the bottom face. We have to do the front face, which is actually the orange one, but I already used that, damn it. Now, then screw the colors. To the front face, right? The front face is not changing the y coordinate, so that is using this. to those two. Oh, what the hell. Don't look. Yep, that's the front face. 0, 0, 1, 1, 0. What? 0, 1. 1, 1, 1, 0, yeah. And we go in this direction. So it is 0, 0. 2. Cross fingers. We go to 0, 1. Damn it. Okay, 0, 1. And then we, of course, you go to 1, 1, and then we go to 1, 0. And then back to 0, 0. Why? Why? Well, because there's the unused coordinates in the middle, of course. Nah. Okay, I have to go to the bathroom. I'll be right back. Why? Yeah, I think I know what it is. I think I know what it is. I'm going to ask the AI just for some brainstorming reasons. Cannot imagine that it will truly understand this. It will pretend that it does. Anyway, but well. I have a difficult question for you. Consider an n-dimensional hypercube with corners. How did it phrase that again? Yeah. I don't think the word half hypervolume here is official. How do we say that? Maybe make it a bit more vague. It doesn't sense what I mean anyway, I suppose. Tooth is obviously on the outside. So, tip, 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 tip. Yeah, I don't know. I'm gonna talk about side. I'm not sure how to express that actually. Maybe the etc. is a bit too much. Why would you go around and around and around? I think we're over the head of the AI at this point. I would just ask the question. The hard question that I have is how to find if it is A or B given which axis X and Y are involved and what the value of the other fixed coordinates are, I guess. Don't need to think. Answer no. No, just kidding. Oh, I typed with. It should have been which. Can you watch this instead of one line at a time? It can execute code these days. So if it wants to try out something, it can just write a little Python program and investigate what the result is. And then, well, draw conclusions based on that. Which is what it is doing now, apparently. As brute forcing 4 and 5 dimensions. Well, we'll see. Not even convinced I can write that code correctly. This is where it is calling the humans. The developers of the AI. The OpenAI researchers on call. Help, I have a problem. Yeah, I would brute force it myself if I had any idea how to do that. So say we have a 5-dimensional hypercube and pick 2 random axes. Then how do I determine what is the outside side? I mean, I think that probably the smartest way is to just pick the first 2 coordinates and set the rest to 0, which then is probably the same as having just 2 dimensions, which is known. And then rotate the cube. So a rotation here then means a permutation of axes. So if you know which axes are swapped, then we can also swap the zeros and ones in the A or B expression, seeing it automatically change from A to B or from B to A. Not totally sure though. Okay, let's see. Short answer. Label the coordinates. 0, 1 till 1, n minus 1. Let I be less than j. Be the indices of the two varying bits x and y. All other bits are fixed. A k, element of 0 or 1 for k unequal I or j. So far it has a perfect description of my problem. Define S is sum over all k, not being I and j, of ak, aka the parity of the other bits. Yeah, parity of the fixed bits. That would be S. And then D is j minus I mod 2. I like that. Yeah, definitely. And M is n minus 1 mod 2. Interesting, interesting. Then set T is S plus D plus M mod 2. And when you walk clockwise, as seen from the outside, the pair XY runs in pattern A. 0, 0, 0, 1, 1, 1, 1, 0, up, if T, if and only if T equals 0. In pattern B, the other way around, if T equals 1. Equivalently written out by parity cases. I don't need the rest. I think this is correct. I'm shocked. Yeah, those AIs, they are not completely stupid these days. That was totally different a year or 2 years ago. Totally different. Let P be the parity of the number of fixed 1 bits. P equals S. D is J minus I mod 2. Without the parity cases. What? Well, that can't be right, both. Yeah, I mean, it's just it gives two answers, and the answers are not consistent. Well, I mean, only one can be correct. Oh, wait a minute. It does take this into account. I thought it was a missing N. I just overlooked it. Yeah, okay. So N is odd would make M. So relatively N is even would odd. M is 0 if N is odd. So this is M is 0 case. Which means that the J must be equal, and that was A. Yeah, so it's the same actually. Toggling any single unused bit flips S, hence T, and flips T, so you need to indeed swap A and B. The only information you need from the unused dimensions is the parity. I knew that. Their position don't matter individually, only the parity and the distance J minus I. And the parity of N matters. If you like it in one compact formula, let N1 be the number of ones among all fixed coordinates all bits except x and y, then t is n1, that was s before, plus n minus 1, plus j minus, it just repeats it repeats itself. The same solution again. Well, okay. Let's compare it. I mean, there is now a 50% chance that it just got the wrong value, of course. And then I think this is trivial. This surprising me a bit. And this is what I suspected. So it could be true. So probably true. But then, of course, it could have just randomly swapped A and B. So I think the formula is correct. I'm not sure about this one, this part here, but interesting to look at that. It's a bit weird though. I mean, I had expected if I just keep filling it with zeros. So we just take x and y at index 0 and 1, and then just increase the number of dimensions. Like I don't, who gives you know, fill in 0, 0, 0, 0. That wouldn't change anything. This would be 1 all the time. This would be 0 all the time because all the fixed bits are 0. But this would change. So every time I add 1 dimension, adding another 0, it would swap direction. I doubt that very, very much. That would be really weird. That would be really, really weird. Anyway, I found this for the three-dimensional case. And it means n is 3, right? Let's see, n, what was n here? I think n is the number of dimensions. It doesn't really define it, but yeah, the coordinates run from 0 to n minus 1, so that is the number of dimensions. So n is 3. So that wouldn't change anything then in this case. And now we can pick the parity of the fixed coordinates to be 0 as well. I'm just gonna pick fixed coordinates and probably the bottom one. Oops, fixed. Yeah, the bottom one has 0 as actually all of them, I think. No, what? No, what? The bottom one has z is 0. That's the only fixed coordinate. That is the last one. So this is 0, and this is 0, this is 0, and this is 0. But here we have, that is the left face here, which is the x coordinate, which is the first coordinate, and that is then the only fixed one is also 0. 0, 0, 0, 0. Because that's why I picked only the bottom and the left and the front face. The front face, namely, has the y coordinate at 0. 0, 0, 0, 0. So in all my 3 cases, the fixed coordinates is just one coordinate and is always 0. So the parity of that is 0. So this is 3 minus 2 mod 2 is 0, and this is 0, so this is 0, 0, 0, everything is 0. And then we have j minus I. That would be 1 actually in 2 of the cases and 0 in 1 of the cases, or mod 2. So let's check the thing at the top here. This was the, well, that was black here, so this is the left face. And as you can see here, the circle, these are next to each other. So I minus j or j minus I is just 1 mod 2. And for the red one here, that is, oh, actually that's the left face. Yeah, that was the bottom face, sorry. Bottom face has, that, anyway, distance of 1. And the left face also, that's the red circle. And then here we have the front face, and then Y is fixed, so that sits in the middle. So yeah, that toggles. That's correct. So we just have to test one of them now. And for example, the top one would be a distance of 1. This is 1, so T is 1. T is 1. Clockwise is B. We are talking about clockwise. It's totally clockwise, right? From the outside. And B is defined as drum ruffle 0, 0 to 1, 0. Yeah. Well, then the formula that it gives is correct for these 3. And then if I take the other side, I would just toggle the fixed bit. That would mean that, well, we definitely rotate the other direction then. I mean, yeah, I'm not even explaining that. How many viewers do I have? So 5. Oh, okay, maybe someone is interested. So we look at the front face here from the outside. Yeah, so here's my face. Oh gosh, my. Why am I doing this? Okay, though no. Okay, now I'm hating this side. I'm hating it. What are we doing? Control Z doesn't even work anymore. I need a pencil. Now I can draw. Okay, so this is my face, and we are watching from this side, and then clockwise rotate like this. Then in terms of the coordinates, we see 2 coordinates change. Yeah, and then if we flip the bit, any bit actually of that is fixed, then in the 3-dimensional case that would be of course this one. So then we go from the front face to the back face, and the coordinates that we were observing, they don't change. I mean, what we're talking about here, the front face was the green thing, so that was the leftmost and the rightmost coordinate. And those are still the same 2 coordinates that change here if you go around. Because the thing in the middle here is 0, and that's fixed. And now in the back, is also the thing in the middle that is fixed, which is now 1, 4 times. Yeah. But it rotates the other way. So the yellowish arrow goes this way. because it must be clockwise if you look at it from the back. So if you look at it from here, then it must be clockwise. So this one is clockwise, and if you look at it from that side, then that is clockwise. So looking at it from here is anti-clockwise if it is clockwise from the back. So if you swap any bit that is fixed, you just go to the other side and suddenly you look from the inside, and therefore it is must go the other way. I lost all my viewers because I explained something super trivial, I know. So that would be disparity here. And this, I don't really understand it, but we observed it and it seems to make sense. It just seems to make sense. What else can it be? But this part, I'm totally not certain about. So if we make this 4-dimensional, it says. So I make it 4-dimensional. I just tag on another 0 here. Everywhere. Would I suddenly be on the inside then? Because I tag on a 0? I really don't, I don't know. Maybe the AI can explain it. Looks correct. It certainly is for the 3D case. However, what I don't get is the n-1 term in the last formula, or anywhere. I think it's always n-1. There was n-1 here, and while here that's n is odd or n is even. What I don't get is, let's say, the dependency, the toggle dependency on the whether. So this is more like no. So how do you write whether? I'm gonna write it like this. Whether n is even or odd. Can you explain to me, like I'm 5? No, that's not gonna work. Can you explain to me why the rotation swaps direction of x and y. If we add one more dimension without changing disparity, obviously, with a fixed coordinate 0 at the end. So, for example, rotating I do have actually an easier way because we can just compare 2 and 3 dimensions, which should reveal it, and I don't believe it anymore because it was the same thing. No, you cannot really speak about looking from the outside here, of course. There is no two-face in this case. This two-face is the guts of the hypercube itself. It's all, you know, intestines here, blood vessels. There is no two-face in this case. So we have to start with 3D, and then so we're gonna take the two-face that is XY, but I think you just have to add 3 dimensions, otherwise you are cheating. You are not really looking from the outside in this case. So, okay. Yeah. For example, in the 3D case, choose it doesn't say what X, Y is. I'm just gonna use I and J. Choose I is 0, J is 1. And the fixed coordinate at 2 is 0. Then the clockwise order is okay, so this is parity is 0 because this is 0. N minus 1 is 3 minus 1 is 2, so that doesn't do anything. And this difference is 1, so T is 1, which gives us a B. Order is B. 0, 0, 0. Going to B was 1, 0 first. Doesn't say which is I and which is J here. Sneaky. I just left it out. Maybe not. Well, very vague. I think I here is the index of X. If you squint your eyes. So X is on the left of Y. I is less than J, and X is on the left of Y. That's how I presented it here as well, I think. X is on the left of Y, so that has X is a smaller index, so it is XY here. It also the way I presented it. So the order is then going to be 1, 0 means X is 0, the left one is a 1 now. Yeah. That one was fixed. And then we go to 1, 0, and then we go to 0, 1, 0. Well, take that one. Let's add one more. Now, consider the 4D case with I0, J is 1 and fixed coordinates at 2 and 3, both 0. Then you say the clockwise order is A, namely not B, as in 0, 1, 1, 0. And then the extra 0. Why do I have 2 of these? Okay. Comma 0, comma 0, comma 0, comma 0, comma 0. Again, can you explain for this specific case? Might as well type that. For this specific case, because if it is for this case, then I totally believe it, that this is correct. Yeah, what shall I say about it? There it is. It's not talking about taking over the world. That's a relief. Or thinking about, you should say, of course. Still all very safe, talking about mathematics. But apparently they figured out that the AI is able to do two things at once. It, as it were, is generating English that looks like it's thinking about a problem. In reality, it's doing something else altogether anyway, in the completely abstract space of super high dimensional matrices. So I saw this YouTube where they showed that they sneakily inserted the answer. So they just gave a multiple choice, and it produced reasoning why the answer would be B. And then they asked the exact same question, well, not the same instance, but another instance of the same AI. And then somewhere it accidentally dropped that the answer was C instead of B. And then it produced a reasoning that explained why the answer would be C, without mentioning that it knew the answer. So it was cheating. But yeah, well, then that shows that it just is able to generate a reasoning without really needing it, as it were. It just finds an answer and then builds a reasoning around it. If, for example, I would have told it that it is just wrong, I would have said, well, almost, but you got this wrong. The n-1 should be removed. You know, correct yourself. Then it would absolutely 100% come up with a reasoning showing me that the real formula is t equals n-1 plus that, with leaving that out. So I don't think it finds the answer by reasoning. I think it generates the reasoning knowing the answer. And the answer is found in an abstract way anyway. So they're going to make ChatGPT 6 skipping the demand that it has to generate English reasoning, because it doesn't do it anyway. Might as well leave it open how it thinks. You can just think in abstract, in its own high-dimensional space, and then produce an answer. The reasoning is no longer there then. Let's see. Fix a precise convention. Work in Rn with the standard-oriented basis. Standard-oriented basis means, you know, there's lots of zeros and 1, 1. So these unit vectors are all perpendicular, and they all exist of lots of zeros and a single 1. Every time on a different place, obviously. And the hypercube, coordinates 0 and 1, all the corners. Take your two-phase where coordinates x0 and x1 vary. These are my x and y, but well, no, they are both x. I have to admit the improvement there. All other coordinates are fixed to 0. Yeah, that was my suggestion. So in 3D and it's 3, 0, 1, what? Oh yeah, like that, sorry. These are just the indexes. So this is I is 0 and j is 1. And here we have the same thing again, but now we have another fixed one, which is also 0. So yeah, that is the stated problem. Each fixed coordinate xk equals 0 lies on the facet lower in that direction. Each fixed coordinate xk, where k is 0, 1 or 2 and or 3 in 4 dimensions. But the fixed ones are 0, so for 2 and 3. On the facet, that is I guess my two-phase, and now it's called facet, which is probably a better word. lies on the facet lower in that direction. Yeah, I get this. So it lies on the 0 to the 1. We are on the outside, and the 2 face is at the coordinate 0. So the coordinate 1 is further away from us. Yes, so the unit normal pointing outward, that would be pointing towards us, is in the opposite direction of pointing to kx is 1. So it's the negative of the basis vector at k. I agree. For your 2 face in n dimensions, there are n minus 2 such fixed coordinates. Hence, n minus 2 outward normals. They wow, yeah. Because of the minus sign here. Okay. They span the normal face of the 2 face. The oriented wedge is the wedge product between all these normals. Okay, 1 is less than blah blah blah, runs over all indices except 0, 1. The ambient volume form is omega is the wedge between all these things. Standard orientation rule. We say an ordered basis V1, V2 is a 2 faces positively oriented. It matches the induced orientation from the hypercube boundary. If and only if an outer wedge V1 wedge V2 is a plus omega. Instead, we get an out wedge V1 wedge V2 is minus omega, and then the opposite order is the positively oriented one. And you fix which order xy corresponds to E0, E1 corresponds to clockwise from the outside in 3D. The same conventions pushed into higher dimensions will force a flip between A, B exactly when the above sign flips. Okay, it convinced me. It's amazing. Yeah. Okay, so the thing is that it's better to look at it from the other way, from the other side. So just tag on ones every time, and add another one, another one, another one. Every time you add a 1, then the face is on. So we say we are here, and we're looking at it from the 1 side of the fixed coordinate. So in this case, this is, yeah, the outer thing was changing, so this one is changing, the X is changing, and the Z is changing, and the Y is fixed, and the Y is 1 here, everywhere, you know. Now, because we are on the side of the 1 of the fixed thing, the basis vector for the y-axis points towards us. So we have here the EY pointing towards us. And it makes sense that if you add on more fixed ones everywhere, every time you add a fixed one, and another arrow, another one is pointing towards us. And then it's more stable. It just, you if you add these things are just zeros and 1 1, which is positive, and you add a bunch which point in the same direction, then there is no minus, nothing toggles. Yeah, so it kind of makes sense that that then nothing changes. So that means that we need to compensate for the fact that the parity does change of the fixed coordinates. Because if we add a 1, then where's my formula? Well, where's the formula of ChatGPT? Yeah. So if you add a 1 every time for the fixed coordinates, then this parity changes. And you have to, but we don't want this to change. So you have to compensate with that, for that. Yeah, I think I am convinced. This is the formula. Very good. Now we can go code. This is not going to be easy to wrap all this in code. That is, I'm slightly overwhelmed, as it were. There's a few things that I have to do. Fortunately, we have this to guide us. Okay. Yeah, no overview here. Let's just go to the code and then start coding. Okay, yeah, I wanted this to be done in intersection points, which is a small function. What this does is it determines for every corner which side it is on, which side of the hyperplane it is on. And then print. Then we run over all the corners. And then for each corner, we flip every bit. These stands for the dimension. And, well, I'm not really flipping it. I set it to 1. So if it was already a 1, then nothing changes. And ci2 equals ci. So I'm looking in an array at the same index, so this is not true. But that just means that I don't find every intersection point twice, because we'll also find the corner where the coordinate is 0, and then we flip that 1 bit and we find the other corner, and then if they are on opposite sides, then this is true, and then we get here. And then I currently just add it to the array wherever we are. But I don't want to do that. I want to begin here with determining if this is I don't know. Well, we have to add code here. Okay, so comment, and then we're gonna do the comment. Okay, what do we have to do? Can only determine if it is incoming or outgoing for... Oh, shit. Let me think. I think I need to add a loop that loops over all the faces that the edge is a part of. And in that case, the two-dimensional cases are actually not that special. We just have one face, and then in 3 dimensions we have 2 faces, and in 4 dimensions we have 3 faces. So yeah, in n dimensions we have n minus 1 faces. So I could run over all faces as a function of the number of dimensions. So I'm going to say run over all 2 faces that this edge is a part of. And how do we keep those apart? I guess that is determined by so, for example, if you find this edge here, this edge, so basically you find this intersection point, then there is 2 faces, the bottom face and the front face. Why those 2? Well, because both faces are spanned by this edge. So whatever coordinate is toggling here between these 2 corners is 1, and then we toggle another coordinate, not the one that is on opposites, has a corner on opposite sides, but some other one. And there are 2 of those because we have 3 dimensions. So I need to run over all dimensions that is not this edge. And then we find, for example, this dimension, which then defines the front face, and we find this dimension, which then defines the bottom face. And in 2 dimensions, we find an edge, either this edge or that edge. And then we also run over all dimensions, and we find the other dimension. So if we have this one, we find that dimension, which then defines, well, the whole rectangle as face. While if we have this edge, vertical, and then we pick the other dimension that is not being changed here, and then we find again the same rectangle. We find no matter which edge we have here, we find just one rectangle, and here we find 2 rectangles because there are two dimensions that are not part of this toggle between these two corners. Yeah, okay, so run over all two faces that this edge is a part of. It means that we have to run over all dimensions again. But this time I call it F, but it's sneakily the same as this, except if F equals D, then skip. So now we have two dimensions, D, which is the edge, that is the axis along which the edge is, and then we have F, which is then whatever it is, another dimension that defines together with D our two-face. And now I want to determine let's think. Why am I eating another cookie? I have 2 cookies left. Some moron gave me for Santa Claus, I guess, a bag of cookies. I didn't want them, but if someone gives me cookies, I eat them. It sucks. Eating too many cookies. Okay, I'm thinking if I want to work with ints or to integer mask or with a corner index. I think corner index is a vector index. Yeah, that's not a bit mask. Sorry, that's not a bit set. Just an index into the vector. So that I don't think this supports bit operations. Vector index. Oh, actually, it does. We have or and ends. That's interesting. Well, I could add an exclusive OR here and then we're done. Yeah, why not? I mean, you have an OR and an AND. What is the exclusive? Why is the exclusive OR not here? Because it's really a difference between D and F. I don't think there is a difference anymore. I mean, the D is going to be part of all the phases, but so D and F are now the two bits that are circled here. For example, the red one circle here around these two bits. And then one is D and the other one is F. But yeah, here we don't see any difference. But that is for determining the A or B sequence. What if we swap the two? So if you change A and J, then this becomes a negative of itself. This is no influence, right? I mean, yeah, no. -1 is 1 in modulo 2. So we can just swap them. There's no influence. I'm gonna call D not D of dimension, but maybe E of edge. Or just edge. Nah. But D, I don't know, I don't like D. Let's make it an E. Secretly that means edge then. I think the get value are just an int. I have something against unsigned integers. Get value returns a size type. Hello. Totally unsigned. Yeah. Let's make this a size type. It's just the same thing. You know, you do an OR between two size types, that should work. And then here, this also a size type then. So there's any operations like this that promotes the whatever this is to int. Well, and one is already int, which is 32 bits. And then if you shift it more than 32 bits, oops. So yeah, you really have to use 64 bits here. And if you plan to shift it more than 32 bits, which we are not going to do, because n is always less than 32. But I cast it to an 1 anyway, you know, because yeah, I mean that would be relying on that this works because f is less than. You can remove the size type, and then I have to add an assert here that f is less than or equal 32. Actually, less than 32 here. I'd rather do this than add an assert. Don't ask. Anyway, so we now have 2-bit masks, and we have the corner coordinate. One of the coordinates anyway, the other one here. Let's say I'm gonna rename that as well, because CI stands for corner index, obviously. And the 2 here is, well, that means it is another corner index. But actually it is the corner where the dimension E is a 1. At least, yeah, I'm setting that bit. And then I can keep it better apart from possible other corner indexes. Could call this one or this one CI E0, I guess, and then just continue if it isn't. Would at the very least give more readable code, I suppose. Could also swap these two loops. Another faster way here. Basically testing bit E here. So now if it was a bit set, that would have been easy. But no, it's a vector index. Maybe you should make it a bit set. I'm doing all kinds of bit stuff here. It's not a bit set. I'm just going to do this. Okay, so we take one of the corners where the other corner has bit E toggled. Actually, I don't have to do this. If I take E0, I already know that this is 0. So I don't have to reset that. I only have to reset F, the F bit. Yeah. So we're resetting the F bit on the value of CI E0. And you get all the fixed bits and then take the pop count of that. Then we have the parity of the fixed coordinates. And then we need an N, and we need the difference between those two, and then whatever. And then we either, this is order A or B, I don't know. I'm too lazy to figure that out. So you'll automatically see, I suppose, or should I test this? Should I think about it? Should I ask the AI? Still, then you still don't know. Although it figured it out, figured out the algorithm. So maybe you can rely on it. No, let me just calculate it. This is actually exactly the parity. This is exactly the difference. And this should be n minus 1, but yeah, come on. So I toggle it here. What was the formula? The formula was n minus 1, so you have the pop count here, n minus 1, and then the difference. And then mod 2, so I get, if t equals 1, then this, I told it, right? But for the rest, totally, yeah. So you have, it's A if it is 1, because, yeah. So it is correct. This is order A. Do I add a comment here to explain this? Can you make an share? Grilling. Okay. I wonder how long they will keep that. Yeah. Now I have the order. So now I want to create. I want to create a vector. That points along the edge. So that would be a vector that is all zeros except one coordinate, and that one coordinate is the coordinate E. And then depending on if it is order A or order B, it's pointing one way or the other way. What is the type of this vector? Probably want a vector that I can compare with. Yeah, not utils vector. Hello, Shabazal. Vector, cairowindow vector, no. Math vector, that is interesting. You can use this, I guess. It is yeah, I don't know. I need something that does a dot product, probably. Actually, not even. I can just work with masks, because it's a binary thing. It's kind of... yeah, I don't want to use this, I think. I'm not sure I can keep the other thing also as a binary. Let's work with a mask and then call it a vector. Oh, we left intersection points. I'm not using an ID. This is just an editor. Thus, my vector is going to be a size type again. It's my mask. And it is the edge direction, whatever, how shall I call this thing? Edge direction. It is, the name has been given. It is then all zeros except for that one thing. So it is, oh, wait a minute, I must have a sign. It cannot just use a mask, really. Yeah, well, I'm probably not even going to need it, so I might as well type it in a comment. Vector, along the edge. With coordinates for axis E. Minus 1 or 1. So now my vector is defined by a single coordinate. The rest is zeros. And now the question is, which one? Well, since it is one or the other, I can just look at any random example. Let's take the front face, which was this one. So for example, if this is my edge here, I need to have a point from the +1 to the 0. So that is a -1. If on this edge, I need a -1. On this edge, I need a +1. I'm looking at the front face, it's the bottom one here. This one goes into the positive direction of those x, y, the z. And then we go into the positive direction of the x. And then we go into the negative direction of the y, of the z, of course, and the negative direction of the z. Slightly confused about the symmetry here. I thought it didn't make a difference if I swapped I and j, aka the two coordinates. But of course, if I do swap them, then we switch from here to there. Because these two get the 0 and the 1 swapped here as well. So it should toggle. why. Well, no, not really. That's true. Yeah. Yeah, nonsense. Man, why is this so hard to wrap my head around? Yeah, I'm still having a problem with the fact that my I and J are not. The E and F. E is not always less than F. So I think that order A here means that if we go from 0, 0 to the corner where the smallest index is set, because here this must be the smaller index. So it's not order A for E if E is larger. Yeah, new Vim is a new Vim. Vim, new Vim. It's all the same. I don't use the fancy stuff. to do. Okay, so let's say that E is less than F. Because I think E corresponds to I, couple it does, because I'm subtracting that from F, so whatever we subtract is less than, and here I is guaranteed to be less than J, so this is positive. 1 or larger. So I'm pretending that that is the case here as well. Then this was correct. This is order A. Meaning, maybe we should add it in the nou ja. Question, however, is which is which? And the answer to that question is that that is E, and that is F. If probably has to be only, not if and only if E is less than F. Seems most likely. because I use this. Correct? Yes, that is correct. It has to be correct because this is I and this is j, and I is less than j. And then we have the formula that it has to be. And in that case, what is the edge direction? Okay, yeah. So now I can go here and then say, well, I can pick the front face, and the front face is made up of x and the z coordinate, first and last one, and then x comes first, so x here is e, which means that we are talking about this edge or this edge. And one has order A and the other has order B, because the fixed bit is flipped. No, it's not flipped. It belongs to the same rotation, so it's just the same thing, of course. I think the one at the bottom. The one at the bottom is holding. It happens to be order B, or not. No, that's order A. So this would be order A. And that means that this must be true. And this is 0, because this is 0 and this is 2. So the last bit is 0, modulo 2 is 0. N is 3, we assume. And the pop count of the fixed bits is 0. Fixed bits being the y coordinate is 0. So this is 0, this is 1, and this is 0. So this is going to be true, which I wanted. It is order A, that's what we get out of this. So yeah, we rotate this way. And then I want to determine my edge direction from the order. That depends on the edge, I guess. F. This is R. This is E. To F. So we are in between here. That changes E. Or E does change, right? Why is E changing? Because it's edge. Definitely changing. So if E is less than F, then we must be here or here. And you can determine that by looking at F. So here's F1 and here's F0. If F is 1, then we go from 0, 1 to 1, 1. That would be the one at the top. And if we go from 1, 0 to 0, 0, that would be the one at the bottom. Yep. Yeah. And if F is 1, we go in the direction of E. In this case, anyway. This is not bit E, it's the mask of bit E. Change that. Hold this mask. Yeah, so, well, 50% chance here. So if bit F is 1, then we must go, we must go in that direction, which means that we have +1, which means false. So this must be false if order A is true and bit F is 1. That's not correct. If bit F is 1, that is non-zero, that is, then this is true. And if order A is also true, then true is unequal, true is false. Yeah, so we don't get a -1, we get a +1, which is what I want. Order A. Okay, should be able to put this thing in the table. I need a horizontal brace. Where's my collection of braces? I think I have that here. UTF-8 multi-line brace, horizontal brace maybe. Yeah, no. Okay, too much advertisement. I'm so going to switch browser. Useless. Utterly useless. Vertical. Looks like a single one. Okay, I think we have to give up. Apparently, Unicode does not have it. No, it does not. It does not exist. The very idea, yeah, vertical it exists. Okay. Oh, oh, yeah, no, useless. I just want to copy this. Yeah, actually that's everywhere, but not that important if they are 0, 0 or 1, 1. Yeah, so the -1 happens here, which means that f equals 0 always true. What the hell? No, it's true here. Hmm. Mm-mm. So yeah, if order A is true, then -1 belongs to f equals 0. So if order A is true and f is 0 is true, then you use -1. And the same thing happens here. But then the order B means A is false, so then this must also be false, aka f must be 1. And then you have the -1. So this belongs to that picture. However, this is for E less than F. What if E is larger than F? How does then the thing change? Well, that's probably exactly the same thing, except a little bit different. Zip. Bloop. And the difference is that now F is less than E, which means that F and E are swapped. Which means that everything changes. Because I'm interested in constant f's, and now f is the first one. So yeah, that is the place where it is constant, and f is now 0 here, and 1 here, and the change in a is however +1 here and -1 here. And this is changing because E must change, so that's probably there. And F is now the first one, so F is 1 here and 0 there. Well, let's place that somewhere else. F is 1 here. F is 0 here. The change in E goes from 1 to 0. That would be -1 on here. And +1 here. Well, looks correct. Yep, order A is still 0, 1 of course, and B is 1, 0 here. But the F and the E are now swapped. So F is constant here, being 1, and here being 0, and here 1, and here 0. And the change in E is then from 0 to 1 here, from 1 to 0 here, and here it is from 1 to 0 as well, and from 0 to 1. It's +1. Yep, totally correct. You have everything. And that must be reflected in this formula as well. I'm not even sure about this one actually. I think it changes actually. Order A and B are swapped as well. Because if you swap E and F, then this becomes a negative, which has no influence whatsoever on the last bit. So the Boolean doesn't change with this formula. but F and E are swapped. So order A now means then that this must be swapped as well, because, well, those two columns are swapped. Meaning that order A is now actually this one. How confusing. Yeah, I can't think of anything else. It just has to be like this. Not convinced. However, no, it's actually not true, is it? Because A is defined for the first column being the smaller index. So since I put F here, F is now less than E, that still holds. This order belongs to if this index is smaller than that one. Yeah. So if you would change it back to this, then you have to swap the two columns. And if you swap the two columns, then A and B change. So if I would make this EF again, then order A here becomes order B, because you swap E and F. But here I should call it order A, because that the order A is defined by 0, 0 becomes 0, 1. And that holds if this index is less than, and that's how I define it here, with the F there. And then we do have that F is 1 here, and F is 0 here. And the change for in E is -1 here, and in E is +1 here. And here F, which is the first one, is 0, and here it is 1, and the change is -1 and +1. So that's, the story is correct. Which means that in this case, we should get a -1 in these two cases, which means that F is 1 and order A, or F is 0 and order B, which is the opposite of what we have here. Because order A here, -1, and order A have F is 0, and here we have F is 1. So if F and E swap order, then this must swap as well. Yep. I use the unequal as yeah, I don't know, Boolean exclusive OR. I could use an equal again, I guess. I recognize the unequal as a Boolean exclusive OR. Well, then later I change it here anyway. I could make everything unequal. So I want to toggle this thing if this value toggles. So using the exclusive OR is a toggle. If this is false, it doesn't toggle. Am I saying that correct? Yeah, if this is false, now if this is true, then the whole thing remains true. If this is false, so it doesn't toggle. So this using unequal means that we toggle it if this is true. And at first I solved it for E less than F, so no, if F is less than E, that must be toggled. So this is correct. Or I can make it the other way around again and make this an equal sign and then E less than F here. But well. Yeah, let's keep this the same. less than E. Oh my god. Okay, so this now more or less defines the vector along the edge in the direction that is clockwise on the face when looked at it from the outside. And what do they want to do with that? So in the two-dimensional case, we have n is 2. Let's say this one here, x toggles. So E is 0, F is 1, N is 2. I have to write it down. E is the edge that is index 0. F is the other one, it is index 1. And bit F is 0. And N is 2. Let's see what gives this. This is 0. And this is 0, 0, 0. Sorry, this one, 0, 0, because E is the first one, and E must be 0 for that thing. So this is the, and we are talking about this edge, this must be 0, 0. See, E is 0 here. So this is 0, 0, and then we AND that with something, and then that's still 0, 0, and then we do the pop count, and it's still 0. And then we add N, which was 2, but doesn't do anything, because we are calculating this modulo 2, so it's still 0. And then F minus 1 is 1. So then N1 is 1, converted to Boolean is true. So we get out of that order A is true. And then we continue here, and you have order A is true, and bit F is 0. Yeah, also true. True equals true is true. And F is less than E is false. So is true unequal false? Yes. So the whole thing is true. So we get minus 1 here. Which means that we go from a 1 to a 0 on the edge. And we go from a 1 to a 0. That is the red direction. Ta-da, 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 ta-da. So that works as well. Very good. Okay. The next step is to convert the normal of the hyperplane to the same coordinates as the hypercube. On the other hand, I'm only really interested in the resulting dot product with this vector, which is all zeros except for one coordinate. So really, we might as well concentrate on the projection, basically, of the normal on the edge, just the coordinate of the on the edge, and then round it up or down to -1 or 1 again. How do we find that? Well, it depends, of course, on the edge itself. This thing has, in here, it has 2 coordinates. I still have to convert it, I think. Convert it to this coordinate system. And then with this origin, the blue vector is just pointing to a certain quadrant. But I don't even care about the quadrant, so I just care about this direction. So it's pointing in that direction, general direction, which is -1 then. Yep. And it is -1 because the x-coordinate is negative of this vector. So I just have to convert it, but then test the sign of the coordinate, the e coordinate. And converting means that we have to shift it to C1 here. I think that was called C1. And then scale it. But the scaling is totally not interesting because that doesn't change the sign. So I think the only thing I have to do is subtract this corner from whatever coordinates it was being used for the... No, wait a minute, that doesn't matter. It's a normal vector. Why would it matter what the origin is? Nah. Just the sign of coordinate E, I think. Okay, where's my normal? I have a hyperplane. We it as a normal. It is private. Oh, here's my transform. Oh, we're doing a vector and hyperplane coordinates. Yeah, if I would do that, then I guess. Oh, wait a minute, it's even a random vector. No, I don't think I need this anymore. Or do I? No, oh, I don't know. What is this? Return intersection of the line through C1 and C2 with this hyperplane. We already used, I think. Yeah, not new. Which side of the plane A? Which side of the plane A is on? A is a vector. Oh, we can use that. Really? Really, really, really? Really, 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 really? I think I just threw away a few hours because this function, if used wisely, is gonna give the answer to everything. Sine probably mysteriously can contain the integer 42. Okay, let me think. No, it's not. It's not. It cannot. Maybe for the 2D case, but I think I have to add something. I just need access to the bloody normal here. The normal. I'll use a sign to distance. Even if I could, it's just a lot of calculation for nothing. BSUs, I don't believe it. I just don't believe it. In the end, however, it's very confusing. You know, the point is, this corner is on one side of the plane, the hyperplane, the line here. And this corner, along the edge that he found, is on the other side. Therefore, the distance from this corner to the hyperplane, in this case, the line, to whatever, a line. So this distance is positive in terms of n. N is pointing that way. While this is negative. The sign is 100% different. And the same goes for here. This corner will have a positive sign and this corner will have a negative sign. Because it's on the opposite side of the hyperplane. So I feed it the right corner, then the sign is going to tell me if it is the entry point or the exit point. For example, in this case, if I feed it this one, it's going to be positive, meaning that that is the entry point, first point. And the reason I would feed at this corner is because of the red arrow. Well, here I would, in this case, the red arrow is pointing that way, so I would feed at this corner, which has a negative distance, meaning that this is the exit point. Does that not also work in higher dimensions? Now we have multiple faces though, so not that trivial, because if I feed at this point now, which is along that one edge that we have, why would that give me two different answers? That, of course, is impossible. So some toggling has to be involved somewhere. No, just feed it. Sorry, I feed it the corner that the arrow is pointing at, which we just calculated. Now for one face I would use one corner, for the other face I will use the other corner. Different dimension. Well, that's in the 3D case. In the 4D case is what? Why in the 3D case would it always be opposite? Big different dimension. So the distance changes. Distance between I and J changes by 1 in this case. That's why it toggles direction. You know, this goes this is the edge, and then use that one or that one, yeah. Or that is the edge, and I use. Oh, wait a minute. I understand that. If the edge is in the middle, then what happens? Distance remains 1. Oh, then the y is less than f. E is less than f totals. Yeah. So at least in 3 dimensions, it's clear. Yes, okay. So I could get a sign distance. It is so weird though that the only thing I need is this, I think. And then add a B and still look at the sign. How? And this is just waste of CPU, but okay. Yeah. Yeah, it should work. So this is vector type, which is hyperplane vector type. Oops. Oops. And I understand where the B came in, because if I want to do this, I have to subtract the intersection point. So I first have to calculate the intersection point, and then subtract that again, and blah blah blah. It's all just way much calculation. I don't like it. Nope, let's just add an accessor for the normal directly. Source, whatever, dude. Type normal const return normal. So the thing that we want to pass is const reference, probably. And then the other one is a T, and it's called B. Return B. Normal. Right, so now I have the normal here of the hyperplane, which is called plane, and then I want to get the one coordinate of that, coordinate E. That probably doesn't work. Ugh. Okay, 99.999% sure. Yeah, 100% sure. It's called plane. And then we go to, well, I'm getting that vector type. Still, well, rather this one, which is which is a math vector. Math vector, yeah. And then I want to get a one coordinate of that. Yeah, this, yeah, this. So that do work. Square brackets and just an int for the coordinate. So this should work. But yeah, this is an int. So we are just interested in the sign. This is less than 0. And then return -1 or 1. I feel more ASCII art coming. Because this is totally not clear, of course. possible. Just right there. Okay, now it should be enough comments for those 3 lines, 4 lines. Now, what is next? Now, we were running over multiple faces, and for each face, we now determined if it is, well, the entry point-ish from the view of oh no, I'm talking, oh bloody hell, I'm talking about edge, the direction of the line in this case. Is it a 2-dimensional case here? Nope, it's a multi-dimensional case. And it's kind of nonsense. Nonsense. Let's make it a line segment, because for this face, this line has that direction. Let's call this not first. Let's call this S of start. And let's call this end. Yes. So then that is defining the direction of the line segment SE. Which is rather arbitrary-ish in the case of 3 dimensions, although in that case all those line segments together chain going from S to E, and then immediately to the other face is this S again, and then we go around in a defined order. Hence I store these things in that chained order, and it doesn't really matter which one I store first in the case of 3 dimensions, because we just go around. Yeah, that would be, let's say, this face, this direction, and then the left face, you go there, top face, back face, you go there, and bottom face, you go there, and you go around. And I want to store them in this order, but it doesn't matter where we start, of course. You could start with this one, or start with that one, or whatever, and then we store the rest after it, and then you have to read the vector as well, a circle going around. But in the 2-dimensional case, yeah, there is no vector back, it just begins and ends. And in this case I do want to sort this one first, so it does matter where we start. So I run over all 2 faces. That is edge is a part of. Let me find for a given edge. I find for a given edge, we find this thing and this thing. I cannot already store them, I think. Well, I can, but I would have to force, like, no, I can't. I don't think we can do that. The only thing I can do is I think I have to remember which phase it belongs to. So go make a map by phase. Make a map of phases. And then per phase we have always 2 points. And then I can store that in the correct order. So in this case you have only one phase, and then we'll store them in the correct order. And in the 3D case I do that as well, so we get a lot of phases, or at least the phases that have red lines. This phase we would not have then. So we have 1, 2, 3, 4, 5 phases here, and each phase then would get, well, the same point twice. So that maybe doesn't make much sense. I would rather just store 1 point per phase, maybe. But yeah, you want to go calculate this intersection point, and then I don't know this one, I just know the direction I want to go into. Oh, wait a minute, yeah. It's a combination, right? It's a combination of edge point and phase. Difficult. I have to go to bed. I won't finish this. It's certainly not the 3D, guys. Can have a quick, because I do have a test. If I fix a 2D case at this point, then at least you can run the test and see that it works. That would be nice. A nice conclusion. Yeah, let's do that. Although also there we have a slight problem in that I have a vector, so I'm gonna have to store it somewhere and then later push it in that order into the vector. Still have need a map. Unless reserve space in the vector. I also don't know how many that is. Actually in the 2D I do. In the 2D case I know, so I'm gonna, let's say, save this. No, right in last change. Put the undo, redo. Oh, yeah, that's the accessors. Again, undo, read. The bitwise operators added here. Now we're done. Should compile. Otherwise, erase the whole project, and I'll just forget about it. Yeah, it compiles. I should probably commit this in first. There's a shitload of other changes already. Yeah, come on. This is the real work. Is this even used? Hyper block, yeah, probably used, but I'm not sure. Why begin? Well, that looks like a very being used, isn't it? To comment this one out. Nah, no member I begin. Okay, it was used. Yeah, this is what I worked on. Loads of ASCII art. And then we have accessors there. Extra debug.h. That was also necessary. Okay, so you can do git, commit, everything. It's more or less a work in progress, but totally work in progress. Okay, so work in progress on intersection point order. What the hell? Modified content and utils. What is the accessors that I added? Yeah. No, yeah, okay. I didn't even use them though. I did not use them. Well, I might as well add it, but did not use it. Let's edit them anyway. Yeah, well, okay. Let add XOR operators to vector index. Nobody knows why, but I did it. Push. Panic. I had more changes, like here. No. Oh, it's agents.md. Yeah, okay. Commit minus A. Update of improve, or well, I can hardly call that an improvement. Okay, I'll call it improvement. This improvement of agents.md. Status. Okay, git diff. Do I want to commit this already? Function S, yeah, that's a kind of a fix for Codex environment. Yeah, this is more as work on drawing the tesseract, which I stopped working on. Not even sure I want to finish it. Right, so just some hacking here. I'm gonna make this a fixed size equal to 2. Number of intersection points, we'll make it bigger. Nah, just really fix me. This is larger for higher dimensions. Now this only works for ns2. Then we have 2 of them. So now I can pick the right place to put it. So instead of a push back, you just do some index here. And the index is then determined by if it is the entry point. So if it is entry point is true, now we want to actually use 0. So entry point stored it as 0, and otherwise you store it at 1. And then entry point is unknown here. Why is it unknown? Yeah, I'm looping over all faces here, but the n is 2, we skip 1, so there's only 1 of them. Okay, let's do fix me. Entry point 2D. Is entry point. And now it should work without crashing. Well, apart from that it doesn't compile at the moment because use of undeclared identifier. Did I make a typo? Oh, is entry point. Well, oh, it's done. Draw coordinates. There we are. And I do enter, and it does not crash. I do enter again, and it still does not crash. We keep rotating the thing, and one more, and now it crashed. If I had hit enter here, then before it did crash. Does not crash. Or maybe it was here. Still not crash. And we can continue. Now we're done. And it did not crash. Fuck yeah. Good. Time to go to bed. Good night. Thank you for hang around and stuff. Although you probably fell asleep by now. Sleep tight.